In America's heartland stands a $500 million engineering marvel, a frozen French fry factory producing 1 million pounds every single day. Americans devour over 4 billion pounds of French fries annually, a global appetite driven by their perfect crisp exterior and fluffy interior.
The French fry originated in late 1700s Belgium, where poor harvests forced locals to fry small potato strips as a fish substitute.
U.S. soldiers in French-speaking Belgium during World War I brought the French fry home, igniting America's love affair. The post-war fast food revolution, led by McDonald's standardization of russet Burbank potatoes, turned fries into a cultural icon. Today, U.S. factories like this one dominate, using advanced engineering to process over 1 million pounds daily with minimal waste. This scale exists because specialized potato varieties and precise machinery maximize yield while controlling costs and quality. Join us inside to discover the science, machinery, and precision that transform humble potatoes into 1 million pounds of perfection daily. Every 1 million pounds of French fries begins here, in America's Potato Belt, Idaho, Washington, and Oregon, where ideal volcanic soils produce over 40% of U.S. potatoes. The russet Burbank, developed in the 1870s and perfected over decades, dominates because its high starch and low sugar content create the ideal fluffy yet crispy fry texture.
Decades of selective breeding target solids above 21% and reducing sugars below 0.3% to ensure even golden color after frying, avoiding unwanted dark ends.
Volcanic ash soils provide perfect drainage and mineral balance at pH 5-6.5. Allowing roots to store maximum starch without excess moisture that causes defects. Precision center pivot systems deliver exactly 1 to 2 inches of water weekly, preventing stress that converts starch to sugar and ruins fry quality.
Self-propelled harvesters gently lift vines, separate tubers via vibrating chains, and minimize bruising. Critical since even small defects are rejected at the factory.
Each truck carries 60 to 70 tons, timed perfectly to supply factories year-round, with storage techniques preserving quality during off-season. From these carefully engineered fields, premium potatoes begin their transformation into 1 million pounds of French fries daily. Every hour, dozens of 60-ton trucks deliver fresh potatoes, supplying the raw material needed for 1 million pounds of fries per day. Hydraulic tippers and high-capacity conveyors unload 30 to 40 tons in minutes, minimizing bruising through cushioned drops and slow belt speeds. Gentle water flumes transport potatoes to storage, using buoyancy to prevent impact damage that could trigger unwanted enzymatic browning. Initial destoners and washers remove field soil, reducing microbial load and preparing tubers for long-term storage without chemical treatments. These engineered silos hold hundreds of thousands of tons, designed with insulated walls and precise climate systems to preserve potato quality year-round. Forced air systems maintain 7 to 10 degrees Celsius and 95% humidity, slowing respiration and inhibiting sprout-forming hormones like gibberellic acid. Cold-induced sweetening is prevented here. Excess sugars would cause dark Maillard reactions during frying, ruining color and flavor. With perfect storage conditions secured, these potatoes are now ready for the high-precision transformation ahead. From climate-controlled storage, potatoes enter the cleaning line, where dirt removal and peeling prepare them for precision cutting ahead.
Deep soak tanks agitate potatoes in warm water, loosening field soil and stones without harsh chemicals to maintain natural quality.
Counter-rotating brushes and 5 to 10 bar sprays mechanically scrub surfaces, removing remaining debris while gentle action prevents bruising. Potatoes enter pressurized steam peelers, the gold standard for efficiency, reducing peel loss by half compared to older methods. At 15 to 20 bar and 160 degrees for 10 to 20 seconds, steam penetrates the skin, vaporizing moisture and breaking pectin bonds in cell walls. At 15 to 20 bar and 160 degrees for 10 to 20 seconds, steam penetrates the skin, vaporizing moisture and breaking pectin bonds in cell walls. Sudden pressure release causes micro-explosions under the skin, cleanly separating peel with minimal starch loss, critical for yield. Residual peel is removed by gentle abrasion brushes, achieving 88 to 92% yield, while peel waste is captured for animal feed or biogas. Advanced filtration recycles over 90% of water, conserving resources as perfectly peeled potatoes advance to cutting. Before cutting, advanced optical sorters scan every potato, rejecting defects that could compromise the final fry's appearance and taste. Multi-wavelength cameras detect color, size, and blemishes at over 10,000 potatoes per minute, using AI to eject flaws with air jets. Vibratory aligners orient potatoes lengthwise, ensuring consistent cut length and maximizing yield from each oblong tuber. Hydrocutting uses pressurized water to propel potatoes through stationary knife grids at high speed for perfectly clean slices. Water acceleration creates shear forces that slice without crushing cells, preventing starch leach that increases oil uptake. Blades are tensioned and aligned to micron accuracy. Different grids produce shoestring, crinkle, or wedge profiles with exact dimensions. Cut geometry directly affects texture. Thinner cuts crisp faster, crinkles increase surface area for extra crunch. With precision cuts complete, the strips now enter blanching to lock in color and prepare for the perfect fry. Freshly cut strips enter blanching, a heat treatment that deactivates enzymes and controls sugars for flawless color and texture. Continuous multi-zone blanchers use precisely zoned temperatures from 90 to 98 degrees to optimize enzyme inactivation and sugar leaching. The heat denatures polyphenol oxidase and peroxidase, preventing oxidative browning that would darken fries during final frying. Counterflow design leaches excess reducing sugars accumulated in storage, avoiding dark spots from uncontrolled Maillard reactions. Each zone is independently controlled, hotter up front for enzyme kill, cooler downstream for gentle sugar extraction. A calibrated dextrose dip restores just enough sugar for uniform golden browning via controlled Maillard reaction chemistry. Vibration removes surface water, preparing strips for drying while preserving the now stable enzymatic profile. With enzymes controlled and color chemistry perfected, the strips are ready for drying and partial frying. Blanched strips first pass through high-velocity air dryers to remove surface moisture before entering the fryer. Air knives at 50 to 80 kph strip away water, reducing oil splatter and final fat content by minimizing steam pockets. Multi-stage forced convection at 70 to 90 degrees Celsius evaporates moisture evenly without over-drying the surface starch layer. Dried strips enter the par fryer, where partial cooking in 175 vegetable oil creates the signature crust. Rapid heat transfer drives moisture outward, gelatinizing interior starch while Maillard reactions begin the golden color. Indirect heating via thermal oil loops ensures plus-homogenious uniformity across the entire 30-meter fryer length. Multi-stage filtration removes particles and maintains low free fatty acids, extending oil life and preventing off flavors. Perfectly par-fried and drained, the strips now head to rapid freezing to lock in this ideal semi-cooked state. Hot par-fried strips immediately enter the IQF tunnel, where rapid freezing locks in moisture and prevents ice damage to cells. Mechanical refrigeration blasts 35 air at high velocity, freezing strips individually in 8 to 12 minutes to avoid clumping. Tiny ice crystals form quickly, minimizing cell disruption so texture remains fluffy after final customer frying. Some lines use cryogenic nitrogen for ultra-fast initial freeze, dropping core temperature below -18 degrees in seconds. Optical systems scan for length, color, and defects, rejecting off-spec strips with precise airbursts at 99% accuracy. X-ray detects internal voids or foreign material, while metal detectors ensure zero contamination risks. Samples undergo fry tests for color, texture, solids, and oil content, guaranteeing every batch meets exacting standards. With quality assured at every level, these frozen fries now move to automated packaging and cold chain distribution. Perfectly frozen fries now enter high-speed packaging lines, where automation ensures precise portions and extended shelf life. Combination weighers calculate optimal bucket combos for gram-accurate fills at over 100 cycles per minute. VFFS systems form, fill, and seal bags from roll stock in one continuous motion, achieving 150 to 200 bags per minute. Nitrogen gas displaces oxygen to below 1%, preventing rancidity and preserving crisp texture during long storage. Impulse or hot bar seals create airtight barriers, while inkjet printers add traceability codes for every batch. Robotic arms palletize up to 2-ton loads in optimized patterns, reducing labor and damage while preparing for shipment. Palletized product enters 18 degrees of storage, maintaining core temperature to prevent quality degradation. Refrigerated trucks complete the unbroken cold chain, delivering 1 million pounds daily to customers worldwide. Every ton of fries produces valuable byproducts, peels and starch sludge that modern factories recycle rather than discard. Peels are dewatered and dried into high-protein feed, diverting thousands of tons annually from landfills to agriculture. Starch sludge feeds anaerobic digesters, where microbes produce methane biogas, powering up to half the factory's energy needs. Closed-loop filtration and evaporation reclaim over 90% of water, dramatically reducing freshwater intake in this water-intensive process. Pulsed electric fields disrupt cell membranes at low temperature, enabling gentler peeling and extraction with 50 to 80% less energy. CRISPR and traditional breeding develop varieties needing less water and resisting disease, securing future raw material supply. AI-driven sorting and robotics push throughput higher while minimizing downtime and resource use through predictive optimization. Through innovation and responsibility, these megafactories produce 1 million pounds daily, sustainably feeding the world today and tomorrow.